Hello friends, in this video we are going to discuss the previous year GATE question number 95. This question is from GATE 2014 examination. Let us read the question. Figure 1 shows the circuit diagram of chopper. Okay, so here we are having a circuit diagram of chopper. Basically it is a buck converter or the step down chopper. The switch S in the circuit in figure 1 is switched such that the voltage VD across the diode actually as the wave shape as shown in figure 2. Okay, so VD is nothing but the voltage across the diode. Okay, it is shown in the second figure. Okay, so this is the waveform of the VD. Okay, next, now the capacitance C is large so that the voltage across it is constant. C is large, so voltage across load is constant. If switch S and diode are ideal, the peak to peak ripple in the inductor current E. Okay, so if you check, the circuit is buck converter. Okay, our task is to find peak to peak ripple current in the inductor. Let us consider the inductor current is IL. Okay, so if you check the circuit for the buck converter, when switch is in a on state, at that time inductor stores the energy and Vd will be equal to 100 volt. Okay, so here if you check, here Vd is 100 volt and it is showing the time is 0.05 second or 0.05 millisecond. So can we say that this time indicates it is a on time of the switch? Yes, because when switch is in a on state, at that time only the voltage across the diode will be is equal to 100 volt. Okay, so here we can say that yes, from the figure we can write on time of the switch, that is a T on, is equal to 0.05 millisecond, 0.05 into 10 to the power minus 3 seconds. Okay, this is the T on. Okay, next, and inductor stores the energy. Next, when switch is in an off state, at that time inductor releases the energy through the diode, so Vd will be 0. So again, if you check the Vd waveform from 0.05 millisecond to zero point 0.1 millisecond, it will be 0 volt, right? 0 volt means it indicates the off time of the switch. Okay, so can we write it as T off is equal to yes, zero point 0.1 milli minus 0.05 milli, so it is equal to 0.1 millisecond minus 0.05 millisecond. Okay, right, so it is equal to, we can write it as 0.05 millisecond only, that is 10 to the power minus 3 second. Okay, this is the T off we are having. Okay, so off time. Okay, so therefore total time T is equal to, yes, it is a 0.1 millisecond only, 0.1 into 10 to the power minus 3 seconds. This is the total time T, right? Next, so here if we draw the waveform of IL, it will be like this. During 0 to T on, it is a inductor storing the energy. T on to T, inductor releases the energy. So IL waveform will be like this. Inductor stores the energy, inductor releases the energy, and again it goes on storing the energy. So it is like a I max, and it is a I min we are having. And here I max minus I min is nothing but delta IL. Okay, this indicates the delta IL. So our task is to find delta IL only. Okay, so now here during T on, can we apply KVL to the loop? During T on means what? It is in the on state, diode will be in the off state. So can we apply KVL to the loop? Yes, it is like plus 100 during T on, yes, or we can draw the circuit. It is like a switch is in the on state. Next, inductor, capacitor, then we are having a load. Next, here it is a 100 volt, voltage 100 volt. Then it is the inductor which is a 1 millihenry. Capacitor we are having, and this is the load. Voltage across load is V0. Okay, so now if you check for this circuit, okay, if I apply KVL to the loop, KVL to outer loop, KVL to outer loop. So it is like plus 100, I am writing here, it is a plus 100 minus 1 into 10 to the power minus 3 into dil by dt. This current is IL. Okay, it will be dil by dt minus v0 is equal to 0. Okay, so what is v0? If you check, it is the buck converter, and in the case of buck converter, v0 is equal to d into vs. Okay, d into vs. So we can write it as, or consider it as equation 1. So let us first find the v0. V0 is equal to d into vs. Okay, for buck converter, what is the d? D is equal to t on by t into vs. Okay, so we know t on is 0.05 millisecond and t is zero point 0.1 millisecond. So it is a 0.05 to 10 to the power minus 3 divided by zero point 0.1 into 10 to the power minus 3 into vs is 100 volt. So it is like a 0.05 by zero point 0.1. So it is like a 1 by 2 into 100. It is a 50 volt. So v0 is equal to 50 volt, right? And d is equal to 1 by 2. Okay, t is equal to t on by t, that is 1 by 2. So now from 1 we can write it as plus 100 minus 1 into 10 to the power minus 3 into dil. What is the dil? During on time, if you check, dil is nothing but the delta il. And what is the dt? It is a t on. So it is a delta il divided by t on. Okay, minus v0, it is a 50, is equal to 0. So therefore 100 minus 50, the 50 is equal to 1 into 10 to the power minus 3 into delta il divided by d into t. T on is nothing but dt. Okay, so therefore we can write delta il is equal to 50 upon 1 into 10 to the power minus 3 into dt. Dt is 0.5, that is the duty cycle, into t is, yes, total time is 0.1 millisecond. Okay, 0.1 into 10 to the power minus 3. So 10 to the power minus 3 minus 3 will get cancelled out. So it is equal to 50 into 0.5 into 0.1 is 2.5 ampere. This is the delta IL, that is the peak to peak ripple in the inductor current. Okay, so this is about the question number 95. Thank you.